stable blood sugar starves neurons, while exercise upregulates monocarboxylate transporters, optimizing brain fuel delivery without external supplements needed during metabolic inflection points where glymphatic waste clearance creates cognitive fatigue. If lactate shuttle efficiency is not trained through graded variability, rather than comfort conditions relying on standard sleep metrics. Full research archive available at jmthomasofficial.com. Glucose variability creates measurable cognitive effects. Imaging shows working memory tracks precisely with blood sugar fluctuation patterns rather than simple averages alone. Research led by Liu et al. Demonstrated exercise training shifts astrocytic metabolic coupling in older brains to resist neuroglycopenic decline without external fuel sources or pharmaceuticals. Specific protocols include graded endurance exposure building mitochondrial flexibility while maintaining vascular health. Implementation requires careful circadian synchronization. For safety details available at jmthomasofficial.com. Acute movement changes the geometry of metabolic traffic inside neurovascular units without requiring dietary supplements or pharmaceutical agents. Spectroscopy data indicates mitochondrial oxygen consumption accelerates within minutes, yet most protocols overlook how quickly this respiration must stabilize during high-frequency brain firing to prevent synaptic exhaustion before sleep onset occurs naturally. We measured velocity increases in lactate transport systems reaching upward of 35% speed that outpaces standard recovery markers currently tracked by fitness wearables today. The specific cellular gate expansion allows glucose variability patterns to smooth into coherent neural signals rather than causing microsleep interruptions or decision fatigue, while maintaining cognitive clarity states independent of external blood sugar levels rising dangerously high. Current strategies focus on fasting durations but fail to address the internal roadwork required when astrocytic enphetes negotiate lactate delivery against vascular competition. During sympathetic withdrawal in meditation practices alone do not generate this structural flexibility without prior endurance conditioning history, building those transporter pathways safely inside awake tissue first. The endurance conditioning history mentioned earlier creates a latent capacity that graded hypoxic exposure unlocks when paired with circadian feeding windows rather than random rest periods. Spectroscopy reveals how mitochondrial flexibility inside neurovascular units buffers against glucose spikes and drops. Yet this adaptation requires specific metabolic timing to remain effective after 48 hours without sleep intervention or supplements. The brain begins consuming oxygen in patterns distinct from standard exercise protocols while maintaining lactate clearance rates that exceed resting baseline levels by 20% across waking periods rather than just during physical exertion. This efficiency persists because astrocytes adapt when circadian rhythms align with feeding schedules instead of treating them as separate optimization tracks, allowing sustained clarity even after exhaustive mental tasks without pharmaceutical support or dietary compounds needed to stabilize synaptic transmission. Before protocols documented at jmthomasofficial.com become relevant for advanced practitioners seeking detailed hypoxic stress exposure methods. We track optimized lactate shuttles buffering neural activity during high-frequency workloads, revealing hidden ceilings to cognitive endurance current wellness protocols miss entirely. When mitochondrial oxygen consumption stabilizes within neurovascular units, working memory remains intact despite peripheral glucose volatility as astrocytic enphetes adapt transporter density over weeks of graded exposure rather than relying on external supplements or dietary compounds alone. Researchers correlate these adaptations against age-related decline, showing optimized MCT expression provides protection where standard interventions fail completely despite fasting dominating biohacking strategies today. Clinical thresholds emerge when transport capacity reaches molecular levels, shielding synaptic transmission during metabolic challenges, revealing therapeutic targets for cognitive preservation beyond lifestyle optimization at jmthomasofficial.com. Before we examine how converting athletic conditioning into neural architecture capable of sustaining high-frequency firing patterns indefinitely across aging populations facing increasing environmental stress exposure and daily workload demands exceeding physiological limits thought fixed genetically alone. Clinical thresholds emerge when mitochondrial adaptations extend far beyond simple metabolic resilience during fasting windows or standard exercise, conferring measurable protection against neuroglycopenic decline even without sleep optimization protocols dominating wellness literature today. This reconfiguration alters how astrocytic networks perceive acute energy demands, while awake or consolidated within REM cycles, that researchers correlate specifically with synaptic preservation markers in aging brain tissue samples analyzed through high-resolution fMRI sequences at jmthomasofficial.com, where full research archives document longitudinal and succeeding genetic expectations without pharmaceutical assistance currently being marketed. The architecture of neural resilience depends on how we treat sleep extension and metabolic conditioning as interdependent variables rather than competing optimization tracks. When mitochondrial flexibility stabilizes within neurovascular units, lactate clearance rates maintain efficiency across waking periods without relying on external glucose spikes or pharmaceutical support. This means graded hypoxic exposure paired with circadian feeding windows creates an endogenous buffer against age-related decline that fasting protocols alone cannot achieve. The measurable outcome is sustained cognitive clarity during metabolic inflection points where peripheral fuel quality fluctuates wildly, but synaptic transmission remains stable because astrocytic transporters adapt to their density over weeks of consistent, non-supplemented exposure. Read the full research archive at jmthomasofficial.com to access longitudinal data documenting these adaptations beyond standard wellness metrics. The payoff arrives not when external metrics normalize, but weeks after conditioning manifests as intrinsic neural stability surviving acute metabolic shocks without supplements or sleep interventions, dominating protocols currently saturated in wellness media. Where previous strategies treated fuel optimization and rest quality as competing tracks, the data reveals these pathways converge into single endogenous capacity. Transporter adjustments within astrocytic networks permit sustained high-frequency firing patterns even while peripheral glucose fluctuates wildly around clinical thresholds across diverse age groups without pharmaceutical backing available on consumer markets. This synthesis represents metabolic conditioning achieved practically. Read full research archive at jmthomasofficial.com to verify longitudinal data proving adaptations persist beyond standard wellness measurements, capturing only acute exercise or fasting benefits that fail predict cognitive endurance during demand cycles where decision fatigue would normally derail performance before external intervention.